Let's see how we can use to solve questions. So we have we're still on quadratic equation. We are still on formula method. Now it says solve the equation 4x squared minus 8x plus 3 equals to 0. Using formula method. Don't forget that x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, what I was talking about is discriminants. That discriminant I was talking about is if they give you a question like this, and you solve only b squared minus 4ac, that is, you solve only this inside the bracket, and you have answers like if it is greater than 0, if this value you are doing greater than 0, that question has a solution. If it equals to 0, you have equal roots. If it's less than 0, it's imaginary. So let's say that, for example, this one. B squared minus 4ac. In this case, what is my A? A equals, this is A, this is B, and this is what? C. Have we? Comparing the general formula, ax squared plus bx plus c equals to 0. So this is for A, this is for B, and this is for what? C. Is that right? Yes, so my A is what? 4. B is what? Minus 8. And C equals to what? 3. Is that right? So from that point, let's find discriminant first. B squared minus 4ac, discriminant D. What is B? Minus 8 squared minus 4 times, what is A? What is C? What is this place? What? 64 minus what? 4 times 3 is 12. 12 times 4, 48. Now 64 minus 48. Sir? 16. So you see that this value is what? Is it greater than 0? So in a case like this, it's going to have a real solution. But if you solve this and you have minus 3, for example, it's imaginary. If you solve this and the answer gives you 0, when you solve the two equations, they will be equal. That's what I'm talking about. So now let's use almighty formula to solve this. X will now be minus into minus 8. Are you following me?
Yes, sir.
Plus or minus the square root of what? B squared. Minus 4 times, what is A?
4.
What is C?
3.
All over 2. What is A?
4.
This what? 8. 64, abi? 4 times 4 times 3.
8.
divided by, have you seen that? You don't cancel this with this, but it's not multiplication that is there. So from that point you have 8 plus or minus square root of 64 minus 48 is what? 16 divided by 8. So that will be 8 plus the root of 16 over 8 plus 8 minus the root of 16 over. You know why I'm putting plus and minus? So what is the root of 16? So 8 plus 4 over 8 plus 8 minus 4 over 8. 8 plus 4 is what? 12. 12 over 8. Or this is, how many can we have? 4. 4 comes in here. 3. Have we? 3 over 2. Or 1 over 2. So that's the answer. To that particular question. Please, I want you to understand that particular point. That discriminant can even help you to get the value of the one you are talking about. So let's see how we can get the theorem. You have a theorem you want to get. If alpha and beta are root of quadratic equation, if alpha and beta are the root of quadratic equation, so theorem. If alpha and beta are roots of the quadratic equation, then the sum of the roots alpha plus beta equals to minus b over a, and the product alpha beta equals to c over a. Let's prove this and see whether it's going to be true. I've brought the theorem that alpha beta is that. So, you know, we have two equations. We have two equations. From what we have gotten there, you know that alpha, you can say let alpha is minus b plus the square root of b squared minus 4ac. Abi? We can call this alpha. Abi? And we call this other one beta. Minus b minus the square root of. Have you seen what I'm doing there? Yes, those are the two equations we have. Minus b plus or minus b squared minus 4ac over 2a minus b. So these are the value we have. We know how to get this. Have you? So let's start with Let's write the beta here. Beta equals to minus b minus the square root of b squared minus 4ac all over 2a. Let's start with that. So in this, we talk about that alpha plus beta is this. Let's confirm. Alpha plus beta. That would be what? What is alpha? Minus b plus b squared minus 4ac plus what is beta? Minus b minus the square root of what? Minus 4ac all over 2a. If you observe critically, you can see with me that this plus and minus are the same. So that will be minus b plus the square root of what? B squared minus 4ac minus b into the root of what? B squared minus 4ac from the partial fraction is 2a. So from there you can see with me that this is plus and this is minus, so you cancel out. If you collect like terms, this and this will come. That will be minus b plus root what? B squared minus 4ac minus root b squared minus 4ac divided by 2a. I collect like terms. Is that right? So this and this is gone. This minus that. Is that true? Yes. So what you now left with now what? What is minus b minus b? Minus 2b over 2a. So 2 cancel 2. So we now left with now with what? Minus b over a. So we have proved that theorem that alpha plus beta equals to what? Minus b over a. We just the start, calm down. Now let's see how we can get the alpha beta. That is, you know that we always know that when they say alpha beta is C over A. So we are going to prove that also. Whether we are going to see this value there. Mathematics is fun. So alpha beta, we multiply. Alpha beta, we multiply. Is that right? Alpha beta, we multiply. So let's see, use this side. I hope you are through with this side. Okay, let me come to this place. I still want to use an elaborate value. So just copy so that we can follow up the corresponding value of x. By the time we finish equation, we are going to solve a lot of questions, a lot of exercise in equation. Most questions are compilation of past questions from so many schools before we enter another topic. So by the time anybody will give any question in equation to any court of law, you will stand and we stand. So unless junction we've been able to get alpha plus beta, right? You know, in most cases I love deriving expressions so that we not forget. Because if you forget, you can have the basis to go back to know where it starts. And from there, you understand what you're doing. You don't quote mathematics. You don't quote mathematics. So let's see how we can go into the alpha beta. Alpha beta, that is a product. You multiply this. This will be minus b plus the square root of b squared minus 4ac all over 2a. We multiply, with minus b minus the square root of b squared minus 4ac all over 2a. Is that true? Product. So when you multiply this, you can agree with me that you multiply the numerator and the numerator and the denominator with the denominator. When you multiply the numerator, we have to take note of sort, because this is sort. So minus b times minus b is what? B squared, abi? Minus b times minus root b squared minus 4ac will now be plus b root what? B squared minus 4ac. Is that true? This times this will now be what? Minus b root of what? B squared minus 4ac. And this time this, the square root will not be there again, because root a times root a is what? A. So root this times root this is root that. So that will now be what? Don't forget there's a plus and there's a minus. That will be minus into b squared minus 4ac. I mean, divided by 2a times 2a, 4a squared. I mean, so this bracket, this minus will affect this bracket. Is that true? So that place will now be, this one is out. Because this plus, this one is what? Minus. So this is out with this. I mean, so what is now left will now be what? B squared. I mean, b squared. Open that bracket, what do you have? Minus b squared plus 4ac all over what? 4a squared. What do we do next? B squared minus b squared is gone. Abi? So what do you have? 4ac over 4a squared. So 4 cancel out 4. Abi? Yes. A cancel 1a. What's now is now what? C over a. Don't forget that law. That alpha beta is what? C over a. That's the stuff. So we have to be disgracing mathematics. In this project, we are going to tell the whole world that mathematics is the simplest course. So together we can achieve mathematics. Roll and flow. Let's speak maths. Hope you are enjoying the class. Yes, sir. Someone is saying exactly. So, since we've been able to derive minus b over a, c over a, we can now be using it to solve a lot of problems. So, if alpha and beta are the root of quadratic equation, it therefore implies that if you bring the two together, we can use it to form something great. So sum of the root and product of the root, you can also get by getting that value. And it is something beautiful to understand the business. So let's see how we can solve problems with alpha, beta, and alpha, beta. So all of us agree that if alpha and beta are roots of the quadratic equation ax squared plus bx plus c equals to 0, it never means that alpha plus beta, and what? Let me say x plus beta and x plus alpha x plus what? Equals to 0. If we add up, and you know in most cases, one of our value is negative. Abi? Is that right? Yes, sir. And it also implies that alpha minus beta and x minus beta, then x minus alpha equals to 0, because in all cases you have a negative value. Abi? So if you expand this, x minus beta, x minus alpha, we can have something like this, which is x squared minus alpha beta minus what? This and this is x squared minus alpha x minus beta x, I mean, plus alpha beta. Negative is minus x is common here. There's a minus and there's x, I mean. So this is going to be x minus alpha plus beta x, I mean, plus alpha beta. Is that true? Is that correct? Equals to what? 0. You can see that I've been able to derive that formula that we say to get the formula to get 2 root is x squared minus alpha beta x plus alpha beta. You understand? So the roots of the equation are given. You can solve that respectively. So we can now summarize from what we've been able to see. You can now summarize from what we've been able to see that alpha plus beta is minus b over a. We've gotten this without quoting, have we? Alpha beta is what? C over a. Is that true? Yes, sir. Then alpha squared plus beta squared equals to alpha plus beta all squared minus 2 alpha beta. We can use, when we get to binomial theorem, I'm going to prove how we get this. Then alpha minus beta all squared will now be alpha plus beta all squared minus 4 alpha beta. And alpha cube plus beta cube equals to alpha plus beta all cube minus 3 alpha beta, then alpha plus beta. Alpha 4 plus beta 4 equals to alpha plus beta. This can be also written as alpha plus beta into alpha squared plus beta squared minus alpha beta. Then alpha to the power of 4 plus beta to the power of 4 equals to alpha plus beta to the power of 4 minus 2 alpha beta, then into 2 into alpha plus beta all squared minus 2 alpha beta. Plus 3 alpha beta. Then 1 over alpha plus 1 over beta equals to alpha plus beta divided by alpha beta. These are the keynote values of alpha beta you need to know, because you are going to use them in solving a lot of problems. So you copy those, because I'm just summarizing certain factors. In this particular business we are doing, if we enter one topic, we are going to read to the fullest. We have to cross all the T's and not all the I's, so that we're going to be solving a lot of questions in equation that touch all facets and all the rules in equation. So how do we apply all this? If they give you questions like this, all the students here, if you are going out of here, you start to teach the whole world. Yes. I think we did example 1, right? This is example 2. It says if alpha and beta are roots of x squared minus 3x plus 1 equals to 0. Find two alpha minus beta 3 alpha cube plus beta cube 4 1 over alpha plus 1 over beta. So with this, you can solve those questions very well. Most of these questions, you see the formulas here, right? So you can solve them. Have you? So let's solve question number 1. Let's do number 1. Alpha squared plus beta squared. Alpha squared plus beta squared. Solution. Number 1, alpha squared plus beta squared. What is the formula for alpha squared plus beta squared? Is what? Alpha plus beta. If you expand this, you get this. Are you getting me? If you expand this is what I'm talking about. You have alpha plus beta all squared minus 2 alpha beta. This is alpha plus beta b minus 2 alpha beta. Expand this. Alpha squared plus alpha beta plus beta squared b minus 2 alpha beta. Is that correct? Yes, sir. So from here you have alpha squared plus what? 2 alpha beta plus what? Beta squared minus 2 alpha beta. This one is plus. This cancel out this, What do you have? Alpha squared plus beta squared. So that is the answer. This one is the same as this. Are you there? So we need to also find at that point the corresponding value of A. We have x squared minus 3x plus 1 equals to 0. So what is the coefficient of, what is A here? A is 1, what is B? Minus 3, and what is C? What you have here is A. What you have here is B. What you have here is C. So we need to get alpha plus beta. Alpha plus beta is what? Minus B over A. Is that true? Which is what? Minus into minus 3. What is A? The answer gives us what? 3. Is that correct? Then alpha beta. Alpha beta is what? C over A. What is my C? What is my A? The answer is 1. So when we now get that, we can now substitute into this formula. So you now say alpha squared plus beta squared will now be equal to alpha plus beta all squared minus 2 alpha beta. From our calculation, we have alpha plus beta equals to what? 3. Happy? So now we have 3 squared minus 2. What is alpha beta? 1. What is 3 squared? Minus 2. What's that minus 2? So that's the answer. As that. So with that, we can solve the question 2, which is alpha minus beta. Question 2, alpha minus beta. So we can get the value alpha minus beta. It has a formula. I don't know whether I've written that particular one for you. That alpha minus beta all squared will now be alpha plus beta all squared minus 4 alpha beta. So we are looking for alpha minus beta, but this one is alpha minus beta all squared. So we can easily get alpha minus beta by squaring both sides. So therefore my alpha minus beta will now become the square root of what? Alpha plus beta all squared minus 4 alpha beta, which now equals to what? We've gotten this already. Happy? That will be 3 squared minus 4 into what is alpha beta? 1. Happy? So from there, now because what is 3 squared? 9 minus 4. What's 9 minus 4? Eh? Square root of 5. You can punch. You can let it be there. So we've done that too. You can do the cube. We have the formula for that. So let's see how we can be able to solve that cube side. Can solve that cube side. X cube plus B cube. This is alpha minus beta. I have been able to square this side. From this you get this. I'm not solving this, I'm solving this. Are you getting me? The relationship that can make us to have this is this. Because alpha minus beta will give us that. So we have been able to get alpha minus beta. So you want to go to alpha cube plus beta cube. So alpha cube plus beta cube. Question number 3. Question number 3. I gave you a relationship to that effect. That alpha cube plus beta cube is alpha plus beta all cube minus 3 alpha beta, then alpha plus beta. So that what is alpha plus beta we have? Alpha plus beta was 3. Minus 3 into alpha beta was 1. Then into alpha beta 3. That will be 27 here. Minus 9. And that will give us 18. It's as simple as that. Now number 4. Number 4 we have one over alpha plus 1 over beta. In this one we can find LCM. I mean, LCM of alpha beta is what? Alpha beta. Is that right? Yes, so this cancel is remaining beta. I mean, this can remain what? Alpha. You know that beta plus alpha is the same thing as saying alpha plus beta, B? Yes. Into alpha beta. We have alpha beta. What's alpha plus beta? What's alpha beta? The answer becomes 3. So if you have that, they say for what value of k are the roots of 3x squared plus k minus 1 x minus equals to 0. For what value of k? We've entered some technical questions now. For what value of k? Most cases, that kind of question you see in exam, they don't ask direct question. So, before you have equal and roots, what does discriminant talks about equal and opposite? What did they say? The question talks about for what value of k are the 3x squared plus 4k minus 8 minus equal and opposite. If the roots are equal and opposite, the root of this equation, 3x squared plus k minus 1x minus 2 equals to, they say they are equal. I mean, if they are equal and opposite, therefore means that the roots, that is, they say the roots are equal and what? Opposite. So if the roots are equal and opposite, that means that would be alpha and minus alpha, not alpha and beta. Because they are equal and what? Opposite. So remember the sum of roots. Sum of roots is what? Minus b over what? So in this case, let me bring a first. What is a? What is b? What is C? Minus 2. So sum of the roots. Sum of roots, which is minus b over a, will now be what? Minus into k minus 1 over what is a? 3. Is that right? I know that this sum of the roots, this is the two roots, Abi? So this is sum of the roots. So if you want to get that value now, that this will be equal to alpha plus minus. Is that right? That is sum of that roots. So at that point, we can agree with me. If you open this bracket, minus k plus 1 over 3, this place is 0. Abi? Is that true? So from there, you can agree with me that if you have minus k plus 1 will now be equal to 0, because this time this is 0. So from there, minus k equals to minus 1 and k equals to 1. So you'll be able to get the value of k. From that, this is a technical question you expect in real root. And so if one of the roots is a cube of the reciprocal of order, if one of the roots, this one was example 3. Example 4. If one of the roots of ax squared plus bx plus c equals to 0 is the cube of the reciprocal of the order, prove that a squared plus c squared all squared equals to ab squared c. Now you can agree that if you have a value where we have some certain, maybe like products and square, you should not forget the sum of the roots and the product of the roots in order for you to be able to solve any question that they gave to you. And you should not expect, in most cases, direct questions. Must use your head. Eh? If you use your head, so in the next 1 minute, you are going to be in an interactive session. So don't forget the basic rules in quadratic equation. One has to do with discriminants. The discriminant of a value that is greater than 0, the discriminant of a value that is less than 0, and the discriminant of a value that equals to 0. It will guide you. And also know some basic laws that envelopes the alpha and the beta, which is the alpha plus beta, alpha, beta, alpha squared plus beta squared, alpha cubed plus beta cubed. All these formulas I'm deriving, when we get to binomial theorem, I am going to derive all of them so that you see. Okay, so now it's time for question. This is question time. This interactive class. Yes. How can it be? Okay, if you solve discriminants, and that answer gives you 0, which of the questions are you talking about? Example 2. Okay. Is it this one? Okay, this is example 3. Correct it. They say for what value of k are the roots of this equation equals to 0? When the roots is equals to 0, what does the discriminant says? When the root is equals to 0, they are what? They are real and equal. Remember, can you answer the question? She's asking, why is this equals to 0? Abi? Okay. Okay, the root being equal and opposite. The roots being equal. If I can understand your question.
When they are equal to 0, they are real. When they are greater than 0.
If you understand the question, let's hear. That's 5 minutes. Yes. Yeah. What's your question? Okay, I understand what you're asking me. The question is that I am saying that the roots are equal and opposite. The time is up. Alright, so the time is equal and opposite. It's because the roots are equal and opposite. If you have alpha as one of the roots, because the two roots, the other roots, assuming you have maybe something like two roots of x plus beta and x minus beta. So for you to have the value, one must be plus and one must be minus. Are you getting me? Because even if you square the minus, you still have this other answer. The root of an equation, if you square minus 2 times minus 2, you still have 4. If you square 2 times 2, you still have 4. So if you call that root alpha, if that root is alpha, we don't know that value. Are you getting me? That value can be negative, can be positive, because the root we are squaring. Are you getting me? So one can be minus, it can be positive. Go on, yes, sir. All right, please. We've exhausted the. It's time for break. Right? 4 minutes. All right. So any question? Any other question? We are interacting. When it's alpha, we did not. The time is up. All right, please. Thank you very much, ladies and gentlemen. When we come back, we start from that point. When we come back. We did not start exactly time. We started like 2 minutes. I will still proceed. All right, 2 more minutes. So please, can I really understand your question? I need to understand your question very well. Have you heard what the guy is asking so that I can answer? We did not start exactly 6. Timekeeper is timing. When it's alpha plus beta, seems to be symmetrical. You have any answer to that? The context of symmetrical is not introduced in this discriminant. Are you getting me? The concept of symmetrical is not linked to this. You have a question? No, we are communicating. We are communicating. This interactive time. So We are still interacting. So when we come, all right. So let's be on our feet and move out for break. Please, you drop those your books and everything there. We now go out for break. Let's go. It's break time. we've been able to like start up some points and let's see how we can solve some certain values. Much examples will be solved right now. Now we are going to pause that one. There's a mistake in that question. It's a mistake. I will rewrite the question again. Okay. Where's that question? There's a book I was holding. Have you given manager? Okay. All right. Now we are still on quadratic equation. And we want to go into evaluation. Evaluation on quadratic equation. Now the first question on evaluation is solve the equation 7 plus 3 x over 2 equals to 5 x over 3. You can see that in this particular evaluation of quadratic equation, we have 7 plus 3x over 2 divided by equals to 5x divided by 3. Now if you see a case like this, the LCM of 2 and 3 is what? 6. Have So what you now do is that you multiply all through by the LCM, which is 6. And now this place will now be 6 times 7 plus 6 times 3x over 2 equals to 6 times 5x over 3. So if you multiply 6 times, then what do you have? 42 plus this cancel is how many times? That will be 9x. How many times? 2. That will be what? 10x. And since we are looking for the value of x, 42 will now be equal to 10x minus 9x. So 42 will now be 10 minus 9 is x. So that x will now be equal to 42. We get the value of x to be 42 in that evaluation. Now the second question of evaluation before we go to another subtopic is if you have x plus 9 over 5 plus 2 plus x over 5 equals to 0. See that the LCM of the down is what? 5. And now, if you multiply through by the LCM, this will now be 5 into x plus 9 over 5 plus 5 into 2 plus x over 5 equals to 0 times 5. So this place will now be cancelling out. You have x plus 9 plus 2 plus x equals to 0. Because if you add up x plus 9 and 2 plus x, you collect like terms, so that x plus x, then 9 plus 2 equals to 0. So x plus is what? 2x plus 9 plus is what? That would be what? 11 equals to 0. So 2x will now be minus 11, and x will now be minus 11 over 2. And that will be x. So how much do you have? 11, 5. Minus our number 1 over 2. So those are the, I'm trying to get evaluation of those ones we've been able to solve. Now before we still proceed on the evaluation, we've been able to understand quadratic equation of alpha and beta. And let's see how we can go into simultaneous equation of one linear and one quadratic. Quadratic equation of one linear and one quadratic. One linear, one quadratic. So we can solve this equation either using substitution method or graphical method in substituting the corresponding value, and we solve. In substitution method, we use one variable. One of the variables in the linear equation is made the subject of its equation. Then the value cut it. Thereafter, we now substitute and proceed. Example of that is, let's see how we can solve this. Solve the equation. The equation solve three x squared plus 4xy minus y squared equals to 1. 2x plus 3y equals to 1. This is one linear and one quadratic. One linear, one quadratic. So if you are asked to solve that, you can use the value of the linear expression and now make either x or y the subject of expression. So here we have solution. X squared plus 4xy minus y squared equals to 1. Equation 1. 2x plus 3y equals to 1. That's equation 2. Now, we use equation 2. We make a subject formula there. So from equation 2, 2x plus 3y equals to 1. We can either make x or we make y subject of formula. Then it never means that 2x will now be 1 minus 3y. And if you now divide through by the division of x will now be what? 1 minus 3y over 2. We can call this equation 3. So you now put equation 3 into equation 1 because we were able to use this equation E2 to get 3. So whenever we see x, we substitute. So that will now be 2 into, this is 3 into what? 1 minus 3y all squared, abi? Plus 4 into what is x? 1 minus 3y over 2, abi? Then we now write our y. Is that correct? Minus y squared equals to 1. Abi? Now from there we see that we have the LCM that is 2. So you have to multiply all through by 2. So multiplying all through by 2, we are going to have 2 times 3 into 1 minus 3y squared plus what? 2 times 4 this square covers up and down. The square covers this up and down now. Okay, this place will now be 4 here. 1 minus 2 to the power of 4. So 2 times. Now let's expand that first. Let's expand this before we find LCM. So this place will now be 3 into 1 minus 3 all squared over 4, then plus 4 into 1 minus 3y over 2, then y minus y squared equals to 1. So from there, LCM will be 4. Abi? Three minus y. So we now expand this. We expand this, we are going to get, the LCM is 4, right? So that will be 4 times 3 into 1 minus 3y over 4, abi? Then plus 4 times 4 into 1 minus 3y over 2, then y, is that correct? Minus y squared equals to 1. So 4 cancel out 4. So you have 3 into, this is 2 of this. So 1 minus 3y, 1 minus 3y equals to, this cancel this 2, have you? 4 times this what? That will be plus 8. Is that true? Into 1 minus 3y, y minus y squared equals to 1. So you can open this bracket. Is that true? So that will be 3 into 1 minus 3y minus 3y plus 3 times this is what? 9. That will be 9y squared. Have you? Plus, open this. Y minus 3y squared. Have you? Minus y squared equals to 1. So this will give us 3 that give us 3 into 1 minus 6y, have you? Plus 9y squared plus, open that bracket, 8y minus 24y squared minus y squared equals to 1. So you now expand this 3. That will give us 3 minus what? 9 times 3. Minus 24y squared minus y squared equals to 1. Is that right? We now collect like terms. 27y squared minus 24y squared minus 18y plus 8y. I mean, this goes with this. This goes with this. We also have another value here, y squared. Let's put the y squared. Then we have brought out 1, 2, and 3. So y is now left to now be what? Minus 18y, then plus 8y equals to 1, 1 minus 3. Is that true? So 27 minus 24 will now be what? That will be 3y squared. This 27 minus 24 is 20. 27 minus 20 is 3. 3 minus y. That place will now be 2y. Minus 18y plus 8 equals to 1 minus 3. So that will be 2y squared minus 10y plus 2 equals to 0. We now multiply, take it out. So from there we multiply this out. Now be 4y squared. 2y squared times 2 is 4y squared. Yes, we can simplify that. If you simplify that, it's going to be easy by dividing all through by 2. So dividing all through by 2, you have y squared minus what? Plus 1 equals to 0. Do you have any factor that can do that for us? Y squared minus 5y plus 1. Let's check that math again. We have y minus 3. That place will now give us 27y minus 24 minus 4y squared. Let's check. If you multiply this, yes. Well, we did not multiply that place by 4. Is it this place? Every other one is correct here. Okay. Let's check that math again. Let's check that math again. There's an objection somewhere. Let's check that math again. You would have gotten a factor here that comes out. The question was 3x squared plus 4xy minus y squared equals to 1. 2x plus 3y equals to 1. Now, we call this equation 1, we call this equation 2. Then from equation 1 we have 2x plus 3y equals to 1. So 2x will now be 1 minus 3y, and x equals to 1 minus 3y over 2. Call this equation 3. So we now put equation 3 into equation 1. That will give us 3 into x, 1 minus 3y, all squared, then squared, plus 4 into x, 1 minus 3y, all over 2. We're able to put the value of 4x, then y, minus y squared, equals to 1. So that will now give us 3 into 1 minus 3y squared over 4, plus 4 into 1 minus 3y, all over 2y minus y squared equals to 1. So the LCM is 4. So multiplying through by 4, you're going to have 4 times 3 into 1 minus 3y squared over 4 minus what? Multiply for the 4 times 4 into 1 minus 3y over 2. Minus what? Then put y. Then minus 4 times what? Y squared equals to 1 times 4. So this will cancel out this. You now left with what? 3 into what? 1 minus 3y. 2 of that, Yeah. This cancels this 2. Is that right? Yeah. Minus 8 into 1. Minus 4y squared equals to 4. So this will now give us 3 into 1 minus 3y plus what? We can open this bracket here. Y minus 3y squared. minus 4y squared equals to 4. So 3 into 1 minus it is what? Minus is y plus 9y squared. Open this by what do you have? Minus 8y plus 24y squared. So we open this bracket, we have 3 minus what? 18y. What's 9 times 3? Huh? Open that bracket. That is that. So we now collect like terms we have 27y squared plus 24y squared. Okay? Minus 4y squared. Do you have another square there? Minus 18y. Minus 8y. You have another y. Equals to 4 minus 3. Have you? So 27 plus 24 minus 4. So minus, let's check 27y, 3 minus 18y plus 27. Do we have plus there? Let's check. This place, we had plus. We had plus, we had plus, we had plus. We had plus. We had plus. Okay? So this place is plus. This plus 8. Then we have 27 plus 24. We multiply 24 there. Let's cross check so that we'll be sure of the business. 3, 24. This and this will now be minus 24. I don't want us to do a mistake. This minus 24. Minus 24. I think it's correct like that. So 27 minus 24 minus y. 27 minus 24 minus 4y minus 18 plus 8y. Abi? So that is very correct. So that subtract 27 minus 24 minus 4. That gives us what? That will be minus y squared. Then it is minus 10y, abi, equals to 1. So you can multiply ultra by minus. Multiply ultra by minus, we have y squared plus 10y equals to, you can cross this one if you have minus 1 equals to 0. Is that right? No, let's just cross over first. Y squared plus 10y equals to minus 1. So therefore y squared, from that point, y squared plus 10y plus 1 equals to 0. So from there, that question cannot factorize. I mean, it cannot factorize. So use almighty formula. So that will give us y squared. Let's just bring out the value. A is what? 1. B is what? Now C is 1. Because from this point we have y squared plus 10y plus 1. So A is 1, B is what? 10, and C is 1. That's the formula, right? Yes, sir. So that will be minus 10 Abi? Right. So we have minus 10. What minus 4 is what? So we are going to have two answers. That will be minus 10 plus or minus. What is the square root of 96? That will be 9.8, Abi? Then 2 times 1. So the answer will not be that y will not be minus 10 So minus 10 plus 9.8 over 2. That will be minus 0.2 divided by 2. Minus 0. Or minus 19.8 divided by 2. So from that point you have, that will be minus 0.1 or minus 19/8 divided by 2 minus 9.9. So that is for y. So when y is minus 0.1, x, recall we were able to get this value of x. We make x object formula. X was what? So that will be 1 minus 3 into minus 0.1. Zero 0.1 times 3. So 1.3 over 2. Zero point 6 what? That's for the plus when x is minus 0.1. When x is minus 9.9, so when x is minus 9.9, what do we have? That's when y is minus 9.9. X will now be 1 minus 3 into minus 9.9 divided by what? 2. Is that correct? So this place will now be what? 1 plus 3 times 9.9. 29.7 over 2. So if you add that, you have that will give us almost 15 what? So that is the value for that particular one. All right, let's proceed. Solve the equation 2x minus y equals to 10. 3x squared now we have two equations, the one linear and one quadratic. One linear and one quadratic. So don't forget that we have to go to the less complicated, which is equation 1. Have we? Yes. We make x subject formula, or we make y. Y is already there. You can make y subject formula there easily. Have we? It's not compulsory you make x all the time. Y is easy to be make subject formula. Is that correct? From equation 1, 2x minus 10 equals to y. Is that correct? I make y subject formula now. Have you? So I don't want to substitute. I got this equation 3. So I want to put equation 3 into equation 2. So let's see how we can do that. So we now put there, we have three x plus y we have substituted the value of y there. Look at this y. I put it here, B. So that place will now be squared. Equals to 22. So from that we have 3x plus. This is 2 of that. That is 2 of that. So now let's see how open this bracket. 2x times 2 is what? That would be 4x squared minus 20x minus 20x 4x squared, then minus 20x minus 20x, I mean?
Yes, sir.
Plus 100. Is that correct?
Yes, sir.
Equals to 22. So from that point, we can agree with me that this will be 4x squared plus 3x minus 20x minus 20x plus 100 minus 22 equals to 0. Is that right?
Yes, sir.
So this is 4x squared, 3 minus 20 minus 20. That would be minus 37. 100 minus 22. So 4x squared minus 3x plus 78 equals to 0. So we can not factorize that place. Can we factorize? What value and what value? Using almighty formula, A equals to 4, B equals to minus 37, and C equals to 78. So we now substitute to that formula. What do we have? We were talking about x. X will now be what? Minus b plus or minus the square root of what? Is that correct?
Yes, sir.
So let's get the value of a. Minus into minus 87. What is b squared? Minus 87b. Abi? Minus 4 times what is a? Two times are 4. Abi? So if you get 37, I multiply with minus, and minus is plus. Abi?
Yes, sir.
Minus and minus is plus. So we now bring it down, we have therefore minus the 7 squared, how place will go first? Can someone press the 7 squared for me? And then that will be 1369. 1369. Four times 4 times 78. So 2 times 4 will give us 8. And if you subtract 87, 1369 from 124, 8. So if you do that, you have 87 you have 37 87 plus 121 all over 8. So let's find the LCM of 121. What do you have? Let us now make 87 Okay, 7 plus 121, that will be, the square root of 121 is 11. So we are going to have two answers, one for plus and one for what? Minus. So therefore x will now be 37 plus 11 over 8, or 37 minus 11 over 8. So the up will be 48 over 8. Then this other one will be 26 over 8. So 46 divided by 8 will give us 6. Now this is over 8. That will be 13 over 4. Or 3.45, anyhow you write. You see the same thing. 3.25. So let's see how we can solve other ones. Alright, I think we have time for question, and I also have time to give you question. Let's just try and solve this for me. Let's check. It's a one linear, one quadratic. Let's just try and solve that. Let's see. Yes. Yes. Can you do that? Very simple. We see God. Very, very simple. And last one. You like mathematics? Huh? Have you tried something? All of you have tried. Have you gotten? Anybody have finished? All right. one linear, one quadratic. It's one of the best and nice questions we always use. Let me try another question and give to you. All right. Your interactive time is off. Okay. You have x minus 2y equals to 1, x squared plus y squared equals to 29. X minus 2y equals to 1, and x squared minus 2 minus x squared plus y equals to 29. Have we solved this particular one? Have you solved it? This question. Five x plus y equals to 9. 3xy plus y squared equals to minus 5. Then 2x squared minus xy x squared minus xy x squared minus xy minus y squared equals to 8, where xy equals to 6. Sir? You've done the first one, and that's what I mean. So let's see how we can tackle that second one. 5x plus y equals to 9. That second one, I hope I can clean this side off. All right, now let's see our question number 2. Five x plus y equals to 9. 3x y plus y squared equals to minus 5. That's the question. Now, solution. We use equation 1 to make y subject. You can still make x subject there, but y is simple. 5x plus y equals to 9. From equation 1, y will be 9 minus 5x. That's equation 3. Abi? So you now put equation 3 in the equation what? 2. This equation 1, this equation 2. So that will be 3xy plus y squared equals to minus 5. Is that right? So you want to put y wherever we see y. 3x into what is y? Plus what is the value of y? 9 minus 5x all squared. Abi? Plus 5 equals to 0. When you cross equality sign, it will turn from minus to what? Plus. Is that right? Yes, sir. So now open this bracket, we have 27x, abi? Minus 15x squared. Then plus, this is 2 of this. Abi? We expand that. Square of that plus 5 equals to 0. Right? So from that point we have if you expand this, 9 times 9 is minus 45x minus 45x. Abi? Plus 5 equals to 0. Is that true? Let's check. This time this 27, this time this minus 15x squared. 9 minus 5, 9 times 9 is 81. 9 times is 45. 45. 9 times 9, 81. 9 times this 45. 9 times this 45. Then 5x times 5x will now be plus 25 x squared. Then plus 5 equals to 0. So from that we now collect like terms. That will be minus 15x squared. Then another x squared there. Plus 25x squared. We are finished with x squared, have we? Now 27 minus 45. You can add up to, you can minus 45 is what? Minus 45 minus 45. That will be minus 90x there. Let's just run 90x. We've gotten x squared. Then 27 minus 90. Have you? That's correct. Now minus 15 plus 25. (27x minus 90). Huh? Minus what? Minus 63x plus 5 equals to 0. Is it factorizable? Okay, is it far from you? Huh? Which one? If you bring this minus 15 here, bring this 25 here, bring this 27 here, we've done this, we've brought this out, we've brought this out, we brought this out, the 5, we add 81 here. So if we add 5 plus 81, we are going to have what? Any objection? That is the value there. Can that one factorize? No. Eh? No. So let's just almighty formula and get the answer. Have you gotten that? It's not factorizable. Abi? It can factorize. What is factorize? What do you have in factorization? Eh? I'm asking him now. Eh? So minus b plus or minus square root of my b squared. What is a? What is c? So that is the value. So minus don't have place to plus, have you? Yes, sir. So that becomes 63. 63 squared is what? 3969. 4 times 10 times 86. Four times 10 times 86. Multiply 2 times and you have 20. Is that right? So that will be 63. What do you have here? Huh? 529. So what is the square root of 526? 20. 5. Tell me 526. 63 plus. What is the square root of that? So from there we can have two answers. Abi? Says what? This is 23. Or 40. It's 3 over 20. What is the answer? That is the business. You can disgrace the question. Now let's see how we can tackle the next question, which is part. We've been able to get the corresponding value. We were able to get only one side of that question. Have you? What were we calculating? So recall that we have been making y subject formula there. Eh? You can do that one now. Eh? For your best interest. This one call for me. Punch again, let me see. So this is divided by 20. Can someone press for me 86 over 20? Not you. Another person can press 86 over 20 for me. 86 over 20. $4.3. So where do you have the 4.32 from? Is it not people that call that value for me? People call that number for me. What you read for me is what I write there. She's correct. It's normal for someone eye to be like that when it's not sleeping. Even your eyes like that, your eyes red. All right. So that was the value. So you can substitute the other one now. So you can complete the other one now. Now let's do the last one for quadratic equation before we proceed. You have two x squared minus xy xy equals to 6. 2y squared, 2x squared minus xy, 2x squared minus xy minus y squared xy All right, I will learn that one is correct. I believe we can do this one.
Yes, sir.
Let's do it together and see. Can we use equation 2 and make x object formula? And put in y? Eh? You can also make x object formula. Equation 1, equation 2. Abi? Solution. For equation 2. X will now be V6 over y. Abi?
Yes.
Is that correct?
Yes, right on.
So we now substitute that. So substitute equation 3 into equation 1. Is that correct? So this plus will now be two x squared minus xy minus y squared equals to 8. That was the original expression. So you want to substitute 3 into that equation 1. Wherever we see x, what do we put? 6 over y. So that will be that will be 2 into 6 over y squared, then minus x minus, I want to believe you are following up.
Yes, sir.
My last ball. So we can expand this. If you now bring this down, you have this can cancel out this. Is that true? So the way we expand that, huh? Have you seen that?
Yes, sir.
Can you complete that for me? You have y4. Can you complete that? What's the LCM there? So we have y4. So multiply by y2. The LCM is y squared. That will now be what? Y squared times 2 in the what? Is that correct?
Yes, sir.
Have you seen what I'm doing there? I multiply ultra by y squared. That place I was squared down to 4. And I get one more. Y squared times y squared. Is saying let's cancel out this. This is over 6 times 2. Huh?
6y squared minus y raised to the power 4 equals to
Now, if you bring out this cancel out this, you have 72 minus 6y squared minus y to the power 4 equals to 8y squared. Happy? So, let's see if you bring all this one here. 72 minus 6y squared minus 8y squared minus y4. This one will stay, this one will stay here, this one will cross. Check whether it's correct. Okay? So from that point we have that this is minus 6 minus 8. Then 72, this and this will give us this, have we? Minus y to the power 4 equals to 0. Now let's take this to the other side, have we? So that we can have corresponding value of y. You have the value of y. So this is going to give us minus 14y squared minus 72. Is that true? Yes, sir. Now multiply, divide through by minus 1. They give you what? Minus 14y plus y to the power 4. Now we can multiply through by minus, have we? Yes, sir. So that place will now be 14 y squared plus y to the power 4 equals to 72. So you can rewrite by saying bring this down, and this other comes here. So bring what? So you have 4 powers. Have you gotten that? So what if you do like this? Is it correct? Is that correct? Yes, sir. Eh? Yes, correct. Remember, is that correct? Eh? So you have 2 answers. Where give us y squared equals to 72 or y squared equals to 14. Or y squared equals to 72 or y squared plus 14. Is that correct? Yes, sir. Professor, have you seen what we are doing here? We are trying to manipulate something big. So from there we have y will now be the square root of or y squared equals to is that 8. You are going to have 2 answers there. Plus or minus 8 point. Eh? So that is 2 answers. Then y squared. 172 minus 14 here. 72 minus 14. Is that right? We'll be able to establish the relationship here for this. We want to talk about this one now. Y squared equals to 58. So y will now be what? We're still going to have 2 answers. Because this quadratic equation will have 4 answers. Eh? Are you learning what I'm doing there? Yes, sir. It's beautiful. So this will now be equals to, what's the equal of 58? Plus or minus 7.6. So we have 2 answers, 4 answers. I forgot a book. So the 2 answers will be y equals to minus 8.5 minus 8.5, 7.6 minus, that's the answers. Eh? Hmm? This is not question time. So with that, you can get the value of x. Abi? Yes, sir. What do you have? Whereby when x is this, when y is this, x is that. Yes. You have to do the value and get it respectively. Huh? So that is a very good example of one linear and one quadratic. Now let's go to the next topic, still on quadratic equation, which has to do with plotting of graph. Has to do with plotting of graph. That is graphical representation of linear. How can you represent some things in linear? Now let's start with one linear and one quadratic. This is solve this linear graphical representation of one linear and one quadratic. Graphical representation of one linear Let me believe that as you're enjoying it in your mouth, you understand it. Not just hearing. So they say solve the following equation graphically. Solve the following equation graphically. Y minus 2x squared plus 5x equals to 1. Y minus x equals to 0. Y minus x equals to 6. It says solve this graphically, taking the value of x taking the value of x taking the value x from minus 3 to 5. Solve the following equation graphically. Y minus 2x plus 5 is equals to 1. Y minus x equals to 6. Taking the value of x from minus 3 to 5. Graphical representation. Hope you can do this. Let's try and see. Now solution. Now if you have this, then you have y now you now bring that value out. Y minus 3x squared plus 4x equals to 1. Now we now draw a line. They gave you the range. Abi? So now let's see how we can fix all those values. We have x given. We have, 2x squared minus yes, I know. Now y minus 2x plus 5x the minus 2x then we have minus 5 y squared minus 2x plus 5x. So this place will now be plus 5x plus 1. This one cross. Y squared. The question was this was equals to 1. So when you cross over, this is y minus 2x squared plus minus 2x squared plus 5x minus 1. So this is 2x equals to 0. So this is 2x squared plus 5x minus 1. We split the given expression to form the table. Have you? 2x squared plus 5x minus 1 or minus 2x, so you just put it like that and fix up those values. I want you guys to do this for me now. Fill this place for me in your book. I will turn around and check. If you do like, you still get the same answer now. Huh? You still have the same answer here. Huh? Is that? Okay, you can do it separately. In that case, you substitute this value here and equate this to 6. I wanted to fix up the two one time. So if you equate this to 6, you have y minus 2x squared plus 5x equals to 1. And in that case, that's a y will now be equals to 2x let me make it for you to understand. Y equals to 2x squared minus 5x plus 1. So, but even if you use the other one, you still have the same answer. So this is going to give us 2x squared minus 5x. When this one turns, the other one is negative. So fix up that, let's get out. That's what we have. Use your hand and fill this space now. Fill everything there in your notes. All this place. I want to check. Yeah. What's the problem? You have assignments in the board. So you know what to do here? Yes, sir. Supremo, you know what to do? Yes, I will come and check now. This x, put it here. Get your answer. Eh? Let me see what you earn. You're not. Alpha. What do you have as an answer? In all. In all 24. Put all these values. Please, that doesn't go. That doesn't go for noise. Hello. If you put minus 3, it's 9. 9 times 2 is 18, okay? This is 4. 4 squared. This is 4 times 2. That is 8. Minus 2 squared is 4. Let's do the second one. $15, 10. Hey, someone say minus 0. Minus 10. Now you now copy this constant. Now the last point is your y. So whatever you get here is the value of y. Put in your book, put in your book. So 18 plus 15 plus 1. 8 plus 18 is, that's 10 plus 8 is 18 plus is 19. 2 plus is 7 plus 1, 8. This is plus 1. Two minus, that will be minus 2. 8 minus 10. 8 minus 10 is minus 2. That will be minus 1. Okay? Now 18 minus 15 is 3. Plus this. That's 2 minus 20. Go for it. What is the answer? So that is the business. I hope you guys understand. All right, now let's see how we can use that to plot the graph. But you have to find the value of y. Abi?
Yes, sir.
So y equals to x plus 6. What is it? Hmm? So for the second graph, you have x, you have plus 6, you have y. So you can solve this one. When I noise too much, you guys don't make much noise. So let's see how we can do this. The plus 6 is constant, it's flows. So we're going to plot our graph. Let's see how we do. Sir? The highest value of y there is 20. Is it 26? This place. Okay, we have 34. Then x, that is, you will not finish x. So. What do you have here? This is 3, 4. This place was plus 6. So. This is 5. This is plus 6. 6 plus 3 is what? This is 6 plus. Now this plus 6. I want to be all of you understand what I'm doing there. So from there we now plot the graph. I want you guys to sketch this graph for me. Sketch the graph in your notes for me. Let me check. Sketch the graph. This 8. It's increasing by 1. I want you guys to sketch the graph for me. I hope you know what to do. Okay? Sketch, let me go. Now let's get the highest value of y. 34. Meaning that we can get 5. No, Shaya won't bother. So we have 34. So let's say 5, 10, 15, 20, 5, 10, 15, 20, 25. For x, the highest value is 11. So 4, 6, 8, 10. Now you don't have a negative value of y. Okay? When x is minus 3, y is 34. X minus 3, y 34. Okay? X minus 2, y 19. X minus 2. X minus 2. X minus 2, y 19. Huh? I want to check something. X minus 3, y 34. You know you have a straight line. X minus 2, y 19. Are you following me?
Yes, sir.
X minus 1, y 8. X minus 1, somewhere here. Y 8. And I think it's somewhere. X minus 1, y 8. X 0, y 1. X 0, y. X 1, y minus 2. X 1, x1, y minus 1, x2, x3, y4, x4, y3, x4, y1. Okay? This one was what? The last one was what? From the graph. Is it here? Huh? This place. 1, 2, 3, 4. X0. X0. Y1. X0, Y1. X is 0. Y is 1. Madam, now. Why do you say it's wrong? X, hold on, X0, Y1. X1, Y minus 2. X1. X1, Y minus 2. No. Go on there. X2, Y minus 1. X1, Y minus 2. X1. 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 This is the one now. I was correct now. Eh? Why are you confusing me? So if you're able to find 2 and minus 1, then 3 and 4. I was even correct in that one now. X4, Y13. X4, Y13. After X4, X2, Y minus 1. X2, Y minus 1. X3, Y4. Okay, X is 3. This is 2. X is 3. Y is 4. X4, Y13. X4, Y13. X4, Y13. Ngamenang. X4. X4, Y13. X5, Y26. The last one, X5, Y26. 5. 26. If you join that graph, you see it's going to be a curve. Have you tried in your notes? You see how you curve the graph? Eh? Yeah. This guy is in. Now, we don't plot this one now. Minus 3, 3. X is minus 3. Minus 2, 4. Minus 1, 5. Minus 3, 3. X. Minus 2, 4. Minus 1, 5. X is minus 1. Zero and 6. When X is 0, Y is 6. X 0. Zero and 6. When X is 0, Y is 6. Which one is now left? 2 and 8. 2 and 8. 3 and 9. 10. When X is 4, Y is 10. It's counting from that point. 5, 11. We can join those points now. According to the way I'm doing my own. If you do it very well, you're going to have a straight line graph. Have you? That's from the way you do it, fine. So where this thing cuts, if you plot the graph very well, you see that where this place cuts is the solution. So, yeah. Let's do it. So we're able to find out the graphical representation of that in a grand style. I can clean this off. That's the graphical representation. So we have finished with quadratic equation. We have been able to cross all the T's and not all the I's. Have you?
Yes, sir. Yes, sir.
So this is another day. This is day 2. We are changing the date to 21st. So in this topic we are going to talk about indices, log and sort. Indices, log and sort. Logarithm. So we're starting with indices. If you have a number x and the product of x is maybe like x times 86 places. That is, you have something like this. This is 1, 2, 3, 4, 5, 6. So that right up is called the nth power of x, and it's called the base. The n power of x, and it's called the base. So that n is the index or power or exponent. Index, power, exponent, anyhow you want to call them. So we have some basic laws that is used in the world of indices. Don't forget that if you have a number x, the product of x from this is called the nth term of the power of x. So the laws. Then x to the power of 6 is called the index notation. It has simple laws. Now the laws of indices. If you don't know any of these at least, we should try of this, because those ones are mathematically affordable. Let's first have kx y that is going to be k in plus y. Base are multiplied. The same base and what you do is that you just take one, add the powers. So example of this is have to the power to the power of 6. Have the same base. So what do you is 2 to 4 because that is which is what now if you have a x the get to the if it log multiplication yeah this one log division to the Now the seventh law said if you have k to the power of 1 over 2, anything you have to the power of 2 becomes the square root of that. Now you have k then I'm saying more. K to the power of a over b equals to the b roots of k or a. The b root of that particular law is fractional index law. So I want to believe you understand those laws. I'm still going to write some laws. Okay. Nice K. All right. Can I clean that off? So, now we've been able to write the law of 8. Now let's see exponential equation. Now in exponential, so the exponential function state that we have If a to the power of x equals a to the power of y, then x equals to y. That's when the base are the same. The power is equals to the same. If bx equals to cy, then so let's see how we can use these laws. Evaluate. Example 1. Now look at that question. 625 to the power of minus 1 over 4 times 1024 to the power of 1 over 10. Hope you can solve that for me. Try, let's do it together. Yeah. I was looking now. What time will you stop? And I break it out. And I break it out. But it's 3. So do you think that 625 has 5, Abi? How many 5 do we have there? Five to the power of 4, eh? Then 1024 to the power of 10. Have you seen that?
Yes, sir.
It's cancelled that you have 5 to the power of minus 1 times, which is going to be equals to 1 over 5. That's that. Then let's see example 2. Evaluate 2 to the power of 0 times 4 to the power of minus 1 over 2. Two to the power of 0. You can do that one now.
Yes, sir.
What's the answer? So 2 to the power of 0 is 1. Times, this is 1 over 4. Is that correct? So from there we have 1 over the square root of 4, which is 1 over 2. One over 2 squared, abi? That's 1 over 4. Now we're progressing to something harder. Simplify it will simplify that math. So you can do that one. You can solve that. So now we split the constant with the constant, the A with the A, the B with the B, and the C with the C. Right? Yes, sir. So that we can simplify it by saying now 40 goes with 8, A goes to A2, B6 goes to B3, C3 goes to C minus 1. Have you seen that? So can 40 cancel 8? 5, have you? A to the power of 4 minus 2, the same base. The same base, you take one base and subtract. You get one on the rest. Is that true? Yes, sir. So this is 5 into A, 4 minus 2. Minus 2. This is C. That is to the power of 4. This one can come down, have you? You take one base here and subtract, take one base and subtract, take one base and subtract. This is 3. 4 minus 2 is 2. 6 minus 3 is 3. 3 minus minus is plus 4. Okay? So this place is 5A squared B3C4. Then all this was to the power of minus 2. So the minus is waiting. Minus is waiting. Minus is waiting. So you now expand that barrel. So that will be 5 to the power of minus 2, A to the power of 5 to the power of minus 2, then A to the power of 2 minus 2, that is 5 to the power of minus 2, A to the power of 2 times minus 2, B to the power of 3 times minus 2, C to the power of 4 times minus 2, 5 to the power of minus 2 into A to the power of minus 4, B to the power of minus 6, C to the power of minus 8. So this place will now be 1 over 25, A to the power of 4, B to the power of 6, C to the power of 8. We can split it one by one. 1 over 5 squared times 1 over A4 times 1 over B6 times 1 over C8. Abi? That will be 1 over 25 A4 B6 C8. Hmm?
Yes, sir. Yes, sir.
Can we proceed?
Yes, sir.
Mami anterior ahí, boludo. So how many hours am I sleeping now? All right. Now we have. Let me clean this side. Now the next question comes this way. Simplify 5 to the power of x simplify that. They have a common base, which is 5, okay? So if you now simplify this, we are going to get 5 5 to the power of x times 5 squared into x minus 1. 5 squared there. 5 to the power of 3. 5 times 5 times 5. 25 times 5, 125. Okay? That will be 5 to the power of 3. Into x plus 1. 5x times 5. You open this bracket, have you?
Yes, sir.
3x plus 3. So you now take one base up because they have the same base and it's multiplication. So you take one base and add, so that place will now be 5 into x plus 2x minus 2 divided by 5 into 3x. So you now subtract. Okay? So that will be 5 into 3x minus 2 minus, is that? This one is 3x minus 2 minus into this one is gone. So now I have 5 to the power of what? So minus 3, 3x minus 3 is gone. 2 minus 3 is minus 1. We can be written as what? So let's check another question. All right. All right, let's see another example. Is that?
2n plus 1 times what?
9n. All right. Which one? Which bracket? Which one? Which question is that?
The last point is this value minus 2 not equals to minus 3 equals to 3x minus 3. That one is gone, but we have the minus 2 is not equals to that place was minus 2 not equals to
Is it the down?
down, yes, the downside is you have the 5 equals 3x. That place is minus 2 not equals to
Okay, this place.
no, it's down. Yes, 3x.
Okay, we get x, 3x. Okay, that place minus 2. Okay, that's minus 2. So that place make it to the 5 to the power of minus 5. Now let's simplify this. Okay, you were talking something. Hope you can solve this one. You can split 6, split 9, and split 4. Are you getting me? This is 3 to the power of 3 and 3 times 2 is 6 into 2n plus 1 times 3 to the power of n times 2 to the power of 2n divided by, we can split 18. 9 times 2, where 9 can also be split to 3. 3 times 2. Abi?
Yes, sir.
This is what? 2 times 2 times 3. Is that true?
Yes, sir.
With that we can finalize.
Yes,
3 to the power of 2n plus 1 times 2 to the power of 2n plus 1. Abi? Times 2 to the power of n times 2 to the power of n times 2 to the power of 2n times 2 to the power of n. You open the bracket. This goes here. This goes here. So coming to the down, we have 3 to the power of n times 3 to the power of n times 2 to the power of n, 2 to the power of n, times 2 to the power of 2n, 2 to the power of 2n, times 2 to the power of 2n. So you're able to split that down. From there, we collect all the like terms together. Abi? All right. Now, since we're able to get that, this place will now be taken to this place. 3 to the power of 2n plus 1 plus n plus n. I just add all the powers of 3. Abi? This, and this. Abi? We've been able to finish that down for the 3. 3n plus n plus 2n, then times 42, 2 to the power of what? Times what? You can just add everything. This is 2n plus 1 plus n plus n. Abi? No. 2 into 2n plus 1 plus 2n plus n divided by, for 2 in that side we have 2 to the power of n plus n plus 2n. We've been able to split that. This plus number 3 into 2 plus 1 plus 1. That will be 4n plus 1 divided into 1, 2 times 2 to the power of 2 times 2 is 4. Now multiply this. This is 2 into 6n. This is m now. You cannot add. N plus n is 2n. Okay, this place was n. This place was n. So that is 6n. Now 3 goes for 3 and 2 goes for 2. So that place will now be 3 into 4n plus 1 minus 4n. Times what? 2 into what? So 4n and 4n is gone. That will be no. Let's check again. 2n plus 1. Let me explain again from the beginning. Let's check. There's 3 times 2 into n plus 1. 3 to the power of 3. To the power of 3n. 2 times 2. 2n. Where?
At the end. Inside.
Yeah. Now 3n, 3n, 2n, 2n here.
The last value.
2n, 2n. This base 2n. So the 2n is here. So minus 4n. So this one and this one is gone.
Yes, the answer is 6.
So the answer is 6.
Yes, sir.
Let's try the next question. All right, let's try and solve this as classwork for me. Simplify x to the power of minus 2, y2, z minus 1, all squared, x to the power of 3. The next one. Let's try and solve that. So have you tried that?
Yes, sir. We are trying.
Anyone have gotten the answer? Anyone have gotten that? Huh?
Z power minus 7, y power 5, z power 4, x minus 7 power, y power 5, z power 4. Let me confirm that. Yes. I have to confirm your answer.
Where do you see G here? Huh? Senior student. Have you tried something?
Yes, sir.
Huh? You? Or just copy and paste. What do you have? What do you have?
Y raised to 5 all over x raised to 7 z raised to 4.
Ishakam. You are still in that same page. Maybe you don't write to the fullest. Maybe you don't do it to the last point.
This was my answer.
Have you guys finished? All of you are having different answers.
X raised to the power minus 7, y raised to the power 5, and z raised to the power minus 4.
Most of you are just sitting down to copy somebody, to have complete notes.
So the answer is y raised to the power 5 over x over 7. The answer is y raised to the power 5 minus all over x over 7.
Should I solve that one?
Yes, sir.
Huh?
Y raised to the power 5 over x raised to the
Hmm?
power
1 minute. Open this, you have x to the power of okay? Now x goes to x. Is it not that? Now minus 4 minus this what? So this one will come down. So come down, become plus. Huh? Say what? What is it? So that one is that. Let's all right. We are going to break now and go to relax. How many minutes are we using?
Please. Let's go outside. Let's go outside. Go outside, let's go. Go outside, some people.